toys.
Let's play.
Oh.
The hottest thing in toys these days are dolls and bears that talk and listen. And the newest thing in PCs may be computers that talk and listen. Will the speech chips move from the toy stores to the computer stores? We'll find out today as we take a look at speech synthesis and voice recognition on today's edition of the Computer Chronicles.
The Computer Chronicles is made possible by Leading Edge, makers of IBM-compatible computer systems, including word processing with spelling correction, communication software, and Hayes-compatible modems. Leading Edge with over 1,000 service centers nationwide. Leading Edge, leading the way to the information age. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.
Cheifet, and with me this week is George Morrow. George, if I want to communicate with this computer, I have to use one of these devices, a keyboard, which most people use, or perhaps a mouse, a joystick, a touch tablet, a trackball, or what some people think is the most intuitive thing, a touch screen, where I can avoid any of these devices and just touch the actual computer display. But when I communicate with you, what do? I talk. That's the most natural thing, but I can't talk to this computer.
That's true, Stewart, but talking is probably the least precise way of communicating. When you talk to this screen, you've got a grid, and you've got to get your finger on the right place in that grid, or it doesn't mean what it ought to mean. When I talk to you, I don't have to finish a sentence. I can get halfway through it with dangling participles, wave my hand, and you know exactly what I mean. But these machines don't have the processing capability to process and understand those things like we do.
George, today we're going to take a look at the latest developments in speech synthesis and voice recognition technology, and we're going to begin with an overview of the current state of the art in using the spoken word for computer input and output.
We're playing
for all those computer users who never learned to type, who disdain keyboards, or who just want a faster way to enter data, voice input and output are becoming realistic alternatives. Kurzweil Applied Intelligence Corporation has a voice-activated system that stores up to 1,000 words. Dr. Alan Robbins, a Boston radiologist, has adapted the Kurzweil system to dictate, edit, and print diagnostic X-ray reports. The system is customized to his voice, after which it can be trained to recognize the verbal equivalents of keyboard macros. A short phrase will trigger a more complete entry in the patient's file. IBM is developing a speech recognizer for office applications based on a statistical model of 25 million words. The AT speech recognizer evaluates verbal entries by comparing them to candidate words stored in the model.
The previous version of this system was implemented on a collection of computers filling a large room, period.
The other half of computer voice technology is synthetic speech.
The Robertson Greeting Card Company. The address is
Call Text from Speech Plus is a text-to-voice simulator that turns ASCII input into speech. GTE of California and Michigan Bell have embraced the idea for rapid database retrieval, when clarity is more important than the subtleties of intonation.
For marketing and electronic speech systems. George?
Charlie, Wrinkles here is one of these talking animals like we've just seen, and it has your stuff in it, I understand. I hope it's not tape recorders.
Oh, no, that's not. That's a talking Wrinkles toy from one of the large toy manufacturers, Coleco to be exact. In that particular toy, there is a microprocessor-based system that does about 1,000 phrases out of that system with tools in it. And it's basically the circuit you're seeing here on the printed circuit board next to me.
But this is a single chip Intel. You're telling me this is all software then?
Well, as you notice, there's no speech
That's
synthesis
right.
chip in there, and so basically we put software in the ROM here, and it actually manufactures speech using the microprocessor.
All time domain stuff.
All time domain and all at low bit rates. Very efficient use of memory.
Roughly how many bits per, I mean, what's my storage requirements on this stuff,
About
Charlie?
600 bytes per word.
I see.
And so you can figure what that would be as far as
Right.
data storage. It's very efficient.
Could we see some of it?
Sure.
Here, let's get Wrinkles away.
Get rid of Wrinkles. Go to the computer.
Okay, what I'm going to do is record a short message, and you're going to see it digitized on the
Okay.
screen and see the waveform. Boy, it's been a great week for me. Didn't see it.
There it is.
There it is, by golly, it's there. Let me play it.
Boy, it's been a great week for me.
Okay, now that's uncompressed or compressed?
That is digitized speech. We strictly have digitized it, and now I'm going to take that data and I'm going to compress it down to about 5,000 bits per second from about 100,000 bits per second. All right, it compressed it down to around 4,000 bits per second. I'll play the original speech.
Boy, it's been a great week for me.
And I'll play the compressed speech.
Boy, it's been a great week for me.
Yeah, there's some difference, but it's not bad.
That's correct.
Now, suppose I'm not particularly happy with it. Is there anything I can do?
Yeah, if you'll see here, this particular product is such that you can edit that particular waveform and make it sound very nice. And here's some of the things you can do. There's a list of commands by which you can change these things and do a lot of different things to the speech waveform. And you can, as you can see, I can mark pitch periods, voiced versus unvoiced, and several things can be done to this to edit and make it sound as natural as you like.
Charlie, besides talking dogs now, what are the serious applications of the technology?
All right, well, some of the things you're seeing in the market now are voice warning systems in aircraft. You're seeing entertainment products, talking slot machines, arcade machines, and what have you. In the space shuttle, there's a lot of reminder systems that are verbal when people have a lot of data at their fingertips and so forth.
At the storage rates they're talking about, this is a very efficient output device.
In a computer, for instance, like an Apple II GS, for instance, with the sound system they have, our particular voice could help people to learn foreign languages and things to hear it pronounced correctly. With low bit rates, you wouldn't use much of the memory of a floppy disk.
Do you see any particular business applications? I mean, using any software that would talk back to you?
Oh, one of the things we're working on with some of the larger companies is voice messaging. And in a computer, where if I wanted to talk to you and you wanted to hear my message in my voice, we can talk into this computer, compress real time. You would get the message back out of the computer, remanufactured at my voice, so you'd understand that. And there are a lot of people interested in doing that right now.
So you can create new messages from information you've already got.
Yes.
That's great.
We just have a little bit of time left. I think you have a pre-recorded, Humphrey Bogart or John F. Kennedy in here to show us how you clean up compressed speech?
That's right. At low bit rates like the 5,000 bits per second, here's what you can get if you like.
I always knew microprocessors could be put to a better use, kid.
And what's the degree of compression on that?
That's at 4,000 bits per second.
Okay, thank you very much, Charlie. In just a minute, we're going to take a look at an application where you can use synthesized speech to access your computer from a remote location. So stay with us. Berkeley Speech Technologies. George.
Mike, we've seen digitized speech. You've got an example of synthesized speech, don't you?
Yes, this is a system that lets you get information over the telephone and read information that's in your computer that's actually stored as ASCII text.
And comes out as synthesized
comes
speech.
out as synthesized, or we say computer speech in general. And for example, one kind of information you want to get very often is names and addresses, and we could start off with trying to get your names.
Okay.
Oh, and there it is.
So, for example, suppose that we wanted to find Stewart Cheifet's name, so we type in Stewart, C-H-E-I-F-E-T, and it says
Stewart Cheifet.
Well, probably a lot of people call you Stewart Cheifet, but you might not like that, so we can then add your name to our dictionary by typing in.
And teach it how to pronounce it
properly. And teach it how to pronounce it properly
so
from then on.
And you're going to use phonemes to do that, right?
Yes. So, C-H-E-I-F-E-T is an sh, f, a, with a stress on the A. Now if I type in
Stewart Cheifet,
it says your name correctly. George has a name that's more, I guess, Scottish, and it works probably pretty well with just the rules by itself.
Should.
George Morrow.
Right.
Fine.
Okay, now show us how you would access a personal computer through a touch-tone phone and get a phone number or an address or something.
Okay, so we're running our program, and the idea here is that you're maybe in an airport or you're in your car with a cellular telephone, and you can't remember the name and address of the guy you're going to see. So you call up using a payphone with any touch-tone type telephone, and you type in using the touch tones the person's name, or as much of the name as you can remember. Now let's say that we wanted to find Stewart's address, and I can remember don't remember how to spell his last name, but his first name I can remember is Stewart. Maybe I can remember that he's a producer, executive producer, Harrisburg, Pennsylvania, something like that.
Okay, so show us.
So we simulate a ring.
Okay.
Hello, this is the Berkeley Speech Technologies remote phone book.
And this is recorded speech.
This is recorded speech. We think
Enter
it's very
your query
important to combine
now,
them.
followed by the pound sign.
All right.
So now I type in, let's say Stewart. So S-T-E-W.
And you're typing in those letters off the touch-tone
typing them in
phone.
on the touch-tone key.
And the software is making sense out of numbers to letters.
Stewart, executive producer, WITF TV. Post Office Box 2954, Harrisburg, Pennsylvania, 17105. Phone number 717-236-6000.
Little speedish.
Well, a couple of comments. It says 2954 and 6000.
Those are the way we find that people read numbers. We've done a lot of work on phone numbers are read differently from addresses, and dollar amounts are read differently. So we can read all those numbers the way we find typical
you'll
Americans
do that
read them.
depending on whether there's a dollar sign in front of it.
Very differently. If you put a dollar sign in front, you'd read it as with thousands and so on. And in England, it would be totally different. So each country and each culture reads the numbers differently. Now, a problem you have with names like my own, O'Malley, it has an apostrophe in it, and that's not on the touch tone. So we
have
use
to
the
do
star.
other things. You have to do other things.
We're not going to have time for the whole typing, but you can use a star as a wild card, basically, for typing in a name like that. And once again, you can access any ASCII file. I mean, it wasn't entered in any unusual way.
And you could have your computer call up a database, keep it locally, and then you'd call in and get it read to you.
Michael, thank you very much. We're going to be back in just a minute with a look at 2 voice recognition systems, so stay with us. In the studio is Janet Baker. Janet's president of Dragon Systems, and George, she's come up with something called the Voice Scribe 1000.
Voice recognition.
Yes.
Janet, for those of us who've been in this business for a while, we think of it as somebody just talking into it as an order entry clerk. Has it moved beyond that?
It certainly has, and that's where the excitement today is. We are really on the verge of a whole new era in speech recognition that's allowing us to do limited dictation and will shortly progress to doing full dictation.
And who's going to use this kind of technology?
Basically, right now, the area where it's having the greatest benefit is for professionals who are very short on data entry skills, who probably don't have dedicated secretarial staff available, and who need to express their expertise in text.
And highly paid. In other words,
Highly
like a lawyer, doctor.
And so what do we
You
have
bet.
up here? This looks like something for a surgeon.
It is indeed. And in fact, it's from a major hospital in Boston. And what it is a surgical report. Let me go ahead and show you. Date. Enter. Patient. James Storer. Enter. Unit number. 173-965-8. Enter. Service. Capitalized word. Orthopedic surgery. Enter. Floor. Capitalized word. White 5. Enter. Surgeon Wexler. Enter. Assistant surgeon Nazarian. Enter. Preoperative diagnosis. Capitalized word. Right thigh, comma, grade, numeral 2, sarcoma involving femoral artery. Enter. Postoperative diagnosis. Same. Enter. Procedure. Capitalized word. Patient underwent general endotracheal anesthesia. Period. Enter.
Now, suppose I had made a mistake, or you had made a mistake there, Janet, while you were entering the information. How do you go back and make a change and edit it?
It's very simple to do. Preoperative diagnosis. Enter. Move up, backward, backward, insert word, spindle, cell, space. Enter.
And that's it.
Okay,
Very simple.
let me ask you a question. A couple times when it looked like it wasn't sure what the word was, it did this sort of pop-up menu. Explain what was going on there.
That's right. It's a very brief rank-ordered list. If the top word is right, I don't do anything. It just implicitly puts it in correctly.
It takes choice number one.
But if it's wrong, if the top word is in fact not right, but the third or fourth one is, I hit the 3 or 4, and it puts in the right word in line.
Very sensible.
All there is to it.
Janet, thank you very much. Well, we may see the letters of the alphabet on the screen, but what a voice recognition system is really working with are building blocks called phonemes and something called a phonetic engine. We have a report on that from Wendy Woods.
One of the reasons that the development of voice recognition systems has gone so slowly is that most developers are trying to get computers to understand words. And you can imagine how difficult a task that is by looking at the size of this dictionary. Well, one of the more revolutionary approaches is getting computers to understand sounds, phonemes, the basic units of human speech, of which there are only about 40 in the English language.
Both programmers and statisticians should be encouraged against transferring.
The phonetic engine of Tarzana, California's speech systems recognizes
Today,
these
should voice other
phonemes,
Payroll. Roll.
understands them as wavelengths, converts them into code, and translates them into text.
The system has a phonetic dictionary, which is much like the dictionary on your desk. On your desk, you look up a word by its spelling and you find out how to pronounce it. Our phonetic dictionary is switched. We look up how a word is pronounced and say how to spell it. A simple example might be the word six versus sticks. The X sound is really a KS sound. In sticks, we spell it KS. In six, we spell it X. There's no way in English to predict those things except by having a dictionary that tells you how we've chosen to spell those words.
Unfortunately, the system's software is slow and doesn't understand words or phrases out of context. But several major manufacturers are impressed enough already to buy quantities of the engine. There will also be a standalone version for PC owners. And Speech Systems plans to be the first to market a true talk writer, a dictation machine that doesn't require a secretary. For the Computer Chronicles, I'm Wendy Woods.
For sales and marketing. And next to Bob is Steve Betancourt, Director of International Marketing with Votan. George?
Robert, Votan puts phonetics to work, is that right?
Not exactly. Our technology is a little bit different than phonetics. We store actual word templates on our voice board, and we do comparisons of those templates to the words spoken into the microphone in a real-time basis.
You've got some really interesting demonstrations for us.
Well, I hope they are. They're kind of indicative of what Votan has been doing in the industry in the last 5 years.
But what we want to see is the application of this voice recognition stuff in a kind of normal businessman's environment. And give us a couple examples there.
Okay, pretend that I'm an executive who came into his office in the morning, and I wanted to talk to my computer to retrieve, certain information. Good afternoon.
Hello, Bob.
Calendar, please.
You have a 10 o'clock appointment with Jim Regano and lunch with your wife. Today is January 10, 1987, and the time is 5:10 p.m.
Now I can go and retrieve email messages or voicemail messages. I'll go and retrieve an email message for you. Any messages?
Please stand by, checking for new messages.
And what's it doing now, Bob?
It's searching the database and the files for various email messages or voicemail messages.
Which might come in over the night or something?
Yes, you have 2 voicemail messages and 1 email message. The first voicemail message was taken at 6:30 p.m. from
Bill White.
The second voicemail message was taken at 7:10 p.m. from Vanessa. Do you care to respond?
Yes.
What function would you like?
Email.
Please stand by while the file is being retrieved and displayed. What function would you like?
Voice append.
Please record your message at the tone.
Mortimer, I'm sorry you don't agree with the $1.5 million quota, so let's make it $2 million instead. I'm tough on my salesman.
Your message is...
Mortimer, I'm sorry you don't agree with the $1.5 million quota. Let's make it $2 million instead.
Do you wish the message sent?
Yes.
To whom?
Eastern Sales.
Message sent. Is there anything else?
Yes.
What function would you like?
Call home.
Now dialing home.
Okay, can we move now, Bob? Suppose I'm working on a spreadsheet. Can I use this for data entry, spoken data entry into a spreadsheet?
That's one application, yes. That's an application we can do. I can bring it up.
Okay,
so you're running something like SuperCalc, and you're actually making data entry, and it's going into the program through your stuff.
Yes.
Okay, is it waiting for you to call home now? Is that what's happening?
It's waiting for the menu to come
back. Oh, you're back
up.
to the menu. Okay, well, let's go to SuperCalc and try that.
SuperCalc.
Now loading the SuperCalc demo.
It's important to note here that this will be a demonstration of continuous recognition. You'll notice there are no need for pauses between any of the inputs that Bob will be making.
Is this because of the template nature of the...
It's primarily because of the algorithmic process we've developed at Votan as part of our leading edge technology.
Okay. But you lay these templates over phrases then?
Correct. It's a user-trained system, and again, this allows us the flexibility in any language, etc.
So we've got a spreadsheet here. Work with it.
November, total revenue, 475, enter. October, direct costs, 476, enter. November, corporate overhead.
Pardon me, but you have a telephone call on line 1.
That's great.
Take a message. Graph.
This is part of the interactive feature. We have the ability to manage the telephone concurrently with applications.
One more thing I want you to show me,
Return.
Bob, is you have an interesting thing where you can use voice input instead of a mouse, in a sense, in a Mac-type application. Could you pull that up?
Yes, sir. Quit.
Are you sure?
Yes.
Steve, while MacDraw is loading, let me ask you a question. You have some deal now with Apple, don't you, to give them Votan voice technology?
Right. We're very excited about an opportunity we have to port this technology into some Apple products, and it's looking very, very good.
Great.
Okay, let's take a look at MacDraw now. We're used to the Mac-type user interface with the mouse, but you're going to use the microphone, aren't you?
Yes, sir. I'll go through it quickly. A normal user would go a lot slower, obviously. File, new, return, edit, cut, return, font, New York, return, layout, reduce to fit, return, file, close, return, quit.
Say yes to exit, no to continue.
Yes.
What a great mouse.
That's impressive and faster than a mouse. Thank you very much. We'll be back in just a minute with this week's Computer News. In the Random Access file this week, your TV and your PC will soon be able to talk to each other. 2 new products just announced this past week may create a new application market bigger than even desktop publishing. A company named A² has announced a video board for the Amiga and the Apple IIgs that will allow the computer to capture and manipulate video signals. That means a home computer user could potentially have the power of a $100,000 video graphics system used by TV stations. The other new product comes from Amiga, the Genlock 1300. This will allow an Amiga user to mix TV, video, and stereo audio signals with the text, sound, and graphics generated by the computer. It's essentially a video desktop publishing system. A Japanese company, Nippon Telegraph and Telephone, is set to announce the development of a 16-megabit dynamic RAM chip. The biggest capacity chip now generally in use is the 1-megabit chip. The 16-meg DRAM chip could hold about 700 pages of text. Experts say the 16-meg chip probably won't become a product until 1990. Tandy is the new king of the hill in retail PC sales. Tandy swamped both Apple and IBM in the fourth quarter of 1986, capturing 37% of retail computer sales, compared to 24% for Apple and only 12% for IBM. There are reports that Atari is having trouble with its just-announced low-cost PC clone. Hang-ups reportedly are FCC approval and a final deal with Digital Research for use of the GEM operating system. Compaq has a new portable set for release. It will have full-size 5¼ drives, a flat-screen gas plasma display, and a 20-megabyte hard drive. The price reported to be about $4,000. Time for a software review, and here's Paul Schindler.
You know, I've tried searching for a job that way, and I've tried searching for a job using a new software package called Super Job Search. I think the software package is a lot more helpful. You see, the most important thing about a job search is to get organized, and that's just what Peter K. Studner's Super Job Search does. It helps you get organized. In fact, it makes it easy to be organized. It guides you step by step through filling out a simple form that describes each job hunting visit. From this one form, Super Job Search can produce 59 different reports. You describe a potential employer or a recruiter. The program helps you keep track of follow-up dates and thank you letters. It asks you who else you contacted, and it has space for notes. Plus, it keeps track of the salary range you discussed and your tax-deductible job hunting expenses. This $30 manual includes forms that go with the software, as well as a lot of practical job hunting advice. This is the kind of sensible utilitarian software I hope we see more of. A good book with good software. Super Job Search is $60 from Gem & Air Limited in Los Angeles. For the Computer Chronicles, I'm Paul Schindler.
Computerland is trying out a new software vending machine which stores programs on a CD-ROM and then writes them to a blank disk when you decide to buy them. The machine is called Hands-On, and it's expected to show up in several hundred Computerland stores. Bottom line is the stores will be able to carry a wider variety of software titles. Digital Equipment Corporation has announced yet another new product, this time a low-cost Microvax 2000, which will sell for about $10,000. The 32-bit desktop computer can run up to 16 terminals in a local area network. The Xerox Palo Alto Research Center is famous for innovation, and now Xerox PARC is working on another new concept, computerized meetings, where each participant at the meeting contributes not by talking, but by directly entering comments onto a computer, which is running and recording the meeting. The system is called Colab, and the developers say it can make a meeting 5 times more productive. Finally, the computer quote of the week: what's the difference between hardware and software? Answer: hardware is something that if you use it long enough, it breaks. Software is something that if you use it long enough, it works. That's it for this week's Chronicles. We'll see you next time.
The Computer Chronicles is made possible by Leading Edge, makers of IBM-compatible computer systems, including word processing with spelling correction, communication software, and Hayes-compatible modems. Leading Edge, with over 1,000 service centers nationwide. Leading Edge, leading the way to the information age. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.